Okay, so we just kind of went through remembering what positive coefficient means, okay, with our odds and evens. So now we're going to focus in, okay, on our degree 3. So yesterday we really focused on our linear equations. How long is that going to take? Okay, because like this is new. Okay, so be quick. Okay, yesterday we focused on degree 1, which was a linear function, and degree 2, which was our quadratic. So today we're just going to, we just wanted to separate them out a little bit. Today we're going to be talking about degree 3. Okay, so our degree 3 is called a cubic. We talked about that briefly. And I want us to take a look at a couple of cubic functions so that we can see what they look like. So polynomial functions of degree 3 is going to be our cubic. In standard form, it's got an x to the power 3, it has an x to the power 2, it has an x to the power 1, and it has a constant. Okay? It may not have all 4 terms, but it will always have at least to the power 3. Because if it didn't have to the power 3, it's no longer a cubic. Okay? It may or may not have a squared term. Okay, it just depends on the function. But in standard form, most of them do. The 2 examples that we're going to take a look at on our calculators have all 4 terms. Okay, so the same thing happens. Just because it's a cubic, okay, it has, let's take a look at the first one. Okay, what's our leading coefficient? What number is it? Yep, -2. So what happens when we have a negative leading coefficient? What does that mean? Negative leading coefficient, we just did this. Yes, down on the right. Okay, so when we are describing this, we're going to say down on the right. Okay, and we're going to remind ourselves that's because we have a negative leading coefficient. Okay, so I can tell you guys, okay, for sure. Those of you who are like, yeah, I'll remember that, okay, if you actually write everything down, when you have your open book chapter test, okay, you will thank yourself for writing down all the notes because then you'll know why certain things happen. Okay, guys, I allowed you to go get a snack. Now zip it, grab out your notes, we're working. Thank you. Okay. Deal with it. And then not again. Okay. Guys, how else can we describe this? We have an odd degree. So are we going to be up or down on the left? With an odd degree. Yeah. Okay, we're going to be up on the left, and that's because, right, they're opposite. If one is down, then the other is up when we have an odd degree. Okay, so let's take a look at what this is going to look like. Okay, so go ahead and pull out your calculator and enter this equation into your y equals. Okay, I'm going to clear out what I have. And don't forget, put in the -2, not -2. Okay, we're going to do -2 x. You'll probably have to use your caret for the cubed. Okay, plus 4x squared minus 3x, okay, plus 1. Okay. Okay, so if you want to zoom in, I'm going to zoom in just a little bit so we can see this a bit more. My window, I'm just going to take to -5 and 5. Okay, guys, here's what's happening. So this is a cubic. Cubics generally have 2 shapes. Okay, a cubic function, okay, is here. I'm going to put it in our notes. Okay, a cubic function is generally either going to have something like this, okay, or it's going to go, okay, with like, so it's either just going to have like a little point where it goes, woo, okay, that's called our point of inflection. Okay, it doesn't change direction, but it kind of has like this pause where it almost feels like it's going to change direction, but then it doesn't. The other form of a cubic is going to have a maximum and a minimum, and then keep going. Yeah.
Can the second form go down as well?
Oh yeah, like the second form can be like that. Yeah, absolutely. Yeah. Okay. Absolutely. Okay, so what I want for you to do is I want you to use your calculator, pull up the table of values, okay, and find a few key points that we can use to plot this graph, okay, into your notes. So for example, like you're looking for nice numbers. So if we look at our table of values, okay, -3 and 100 is not very helpful. Okay, that's not going to be anywhere on our graph. Okay, so we're probably going to take -110, 0, 1, 1, 0, 2, -5. Okay, we're going to take those for a start. Okay, then we're going to have to pick a couple other ones. Okay, so write those ones down. Okay, just off to the side, make like a nice table of values. -110, 0, 1, 1, 0, 2, -5. Okay, so -110, 0, 1, 1, 0, 2, -5. Okay, this is what I have so far. If I'm using, okay, this is also very helpful. Okay, label your graph with what your scale is. Okay, so if you are like, if you're ever zooming in, or maybe your scale is like you're counting by hundreds for something, because like we've got a really, like we have really big numbers in our function, okay, you can indicate that here. So we just say X scale is 1 and the Y scale is 1, so that we know that it's true to our coordinate system. Right? So from here, and you're looking at your graph for reference. Okay, you know that it's going to go through this 0, 1, and then it's going to have like a little bit of a, what's called a point of inflection. So it looks like this, it's coming down. Okay, so this is an example of a point of inflection. Remember on your homework questions last night, it asked you for, like, it said turning point, and you were looking at that going, what's a turning point? And I said, if it's a min or a max, that's a turning point. Do you think a point of inflection would be a turning point? That's right. So a point of inflection is actually not a turning point. It's a point of inflection because it doesn't change direction. Okay, a turning point has to, it's only a min or a max where you're going up and then suddenly you've changed direction and you're going down. Okay, or you were going down, you hit a minimum, you change direction and now you're going up. So just so you know, a point of inflection, okay, this is not a turning point. I guarantee you there will be a question that will give you a cubic and it will say how many turning points. And it will give you like 0, 1, 2, or 3. Okay, and if it's a point of inflection, you might be tempted to say there's 1. Okay, but there's not. There are no turning points. Okay, what was our y-intercept? Okay, you have 2 ways to do this. You can pull this out of your table of values, or you can go to your calculator, right? And your y-intercept is where x is equal to 0. So you could actually go trace, and it will tell you, and you hit at 0, enter, and it will tell you when x is equal to 0, y is equal to 1. Okay, so your y-intercept is at 0, 1. Or, okay, guys, this is still your y-intercept. Okay, we're going to finish up this one. What are the number of x-intercepts? How many x-intercepts do we have? Yep.
Wouldn't the y-intercept be 1 and 0?
No, x, y. That's okay. Yep, x and then y. Okay, there's one x-intercept. Guys, is there any restriction on x?
No.
No. Good job.
Restriction on y.
And there's no restriction on y. And turning point. Okay, there's no turning points because a point, instead, it has a point of inflection. Okay. Enjoy your weekend. Okay, and we will continue looking at degree-free polynomials on Monday.